All right, sweet. Like we did in the last lesson, we're just going to run through questions that you guys have sent. And I'm no longer picking questions. I am just working out the questions that you've sent me, which shows me that we are getting some work done and getting stuck here and there. And that's what our job is, to make sure that we sort whatever is outstanding out. All right. 1 second, guys. I'm just going to quickly take this call. I'll get back to you quickly. All right, guys, I'm going to put up a question. Start working. Just quickly taking this call very fast. Okay, guys, here we go. Electric circuit question. Let's see. We're going to run quickly because I want to cover as many questions as possible. It's just having a lot of things to deal with now. All right. A battery of EMF 12 and internal resistance 0,2 is connected to 3 resistors, high resistance voltmeter, and 2 switches. Okay, an ammeter and connecting wires. As shown in the circuit diagram below, the three resistors have different. Please take note, they always either use the word identical or different. If they're identical, then the R values are the same. But now we are specifically told that they are different. That's a very important information that they've given us. All right, the resistance of Y is twice. Now, once I see that, you know what I do? I make mathematics out of it. Ry is 2 times Rx. Let's go and put it there. Ry is 2 times Rx. So this is 2Rx. Important. When both switches are closed, the reading on the ammeter is 5,5. Let's write it there. I don't know who sent me this question, but if this is your question, congrats, we're dealing with it now. Okay. Give a reason why there's no current through RZ. Okay. Wait, both switches are closed. The reading is 5,5. Give a reason why there is no current through RZ. Interesting. If both switches are closed. All right. Oh, lovely. Lovely. Can somebody answer this? This is very beautiful. I'll give you a hint. A switch has 0 resistance. Very little, so we call it 0 resistance. So what's happening here when I put the switch there? Let's see. Let me get answers. Current takes the part of least resistance. All right. The short circuit current. Thank you very much. All right. So already by this switch being closed, we have a short circuit. I don't know if I've demonstrated this for you before. All right. The switch creates a short circuit. I don't know if I've demonstrated this for you before. The switch creates a short circuit. Some of you, I think I even did this in grade 11. Let me see if I have my 3rd here. Because Some of you just take that information and you don't really know what's going on. Did I delete? Two. All right, even if it's deleted, let me do this. I'm going to quickly show you now what this means. So we can understand what short circuit means. It will really assist us in dealing with a few questions. And while I'm on this, I'm going to draw a graph. All right, and show you where the short circuit thing is on the graph. Okay, what's a graph? FET Colorado. You can download this. Just show you that short circuit so that you believe in what we're saying and understand what we mean by short circuit. Okay, run. Physics. All right, I don't know why this is so slow today, but okay, let's see what is going on. All right, let me do this. Let's continue with the question I'll install. All right, there we go. We have it now. I go to lab. Just a very simple one. All right, there we go. So we have our battery there. Just going to get a wire. All right. We have that. I'm going to put a light bulb there. Got a wire there. And I'm going to get another wire. No, I'm going to get a wire here. And where is my switch? There's something I wanted. Okay, I'll fix it. Now that's my switch. When I close this particular one, we have light. Now check what I'm going to do. I'm going to short circuit by creating, let me put another switch here. All right, current will still flow. We have no problem. But immediately I close the switch because the switch has zero resistance. That's what happens. It goes off. Okay, I hope short circuit makes sense to you now. You can see all the electrons are now flowing through a path where there is zero what? Resistance. I hope you can see a switch has a zero. Look at the value of the resistance there. It's infinitesimally small. All right. I hope we're good. Now, calculate the resistance of Ry. Let's see. What can we talk about here? What I'm going to say is, let's combine. Let us combine so, guys, Rx is not working. All right? I is equal to what? 0. I there is equal to 0. What do we know? If we were to combine this whole thing, I can safely do this. right? And we have a 5,5. But this guy is not working. So, can I just throw it out? Will that be fine? Will that be okay? Now here, this is my parallel connection. Let's find our parallel. Our parallel, we can say, is product over what? Sum. And that will give us what? Rx multiplied by 2Rx over Rx plus 2Rx. What would this give us? 2Rx squared over what? 3Rx. And if we divide, what do we have? We have 2 over 3Rx. That is my total. If I can get Rx, I'll get Ry. Okay. We know current. EMF is I into bracket R plus R. What is my EMF? 12. Do I know current? Total current? Yes, 5,5. My total resistance outside now is 2 over 3Rx. And my internal is 0,2. Please do the maths, get me Rx. And once you get me Rx, get me Ry. Because we said Ry is 2Rx. Quickly, everybody, let's get the math done. Let's get the math done. All right, I'm seeing 2,97. Is that correct? Which one is this? Is that Rx? We divide both sides by 5,5. Let's increase my pace now. 12 divided by 5,5 would give me that. And minus, take the 0,2 over that. And then divided by 2 over 3. 2,97. Now remember, what is Ry? That's what we are looking for. We said Ry is 2Rx. What are we going to get? We have 4 there. 9 here would give us 8. And that would be what? 5,84 ohms. Do we agree with the calculation? Let me know. Give me a thumbs up. Do we agree with the calculation? Are you okay? Are we on the same page? Anybody lost? Oh, if you multiply what you got earlier on by 2, right, without breaking it down, Arifa, you have 5,95. Awesome. Thank you, Amara. Good. Calculate the power dissipated in Rx. Guys, once you know the value, it's now easy to work. What do we know now? Let's quickly create a second page here and we move. Circuit is now done. No one should have issues with circuit again. So this is 2,9 what? 7 ohms. What do we know, guys? How do we calculate power? We are looking for Rx. Power in Rx. How are we going to get that? Power is IV. Just look at the formulas. Power is V squared over R. Power is I squared R. Question is, do we know I? No, we don't, guys. Please always remember, we don't know I. Why am I saying? Somebody saying, but we do. No, we don't. If I look at that, and I'm going to quickly do two things here to also guide you on multiple choice. Parallel are current what? Dividers. Current is divided. So we have 5, 5. This is Rx, and this is 2Rx in the ratio 1 to 2. What do we know? Let's calculate current in different ways, my dear learners. Let's calculate current in different ways. I want to show you different ways, and we must get the same answer. First thing I want to quickly tell us is we can get our V external, right? V external, something we can get. All right? V external. I multiplied by R, or you can say E minus I. So many ways. So many ways. Look at this. 12 minus 5, 5 multiplied by 0, 2. All right. What is 5, 5 times? All right. 5, 5 times 0, 2. Isn't that 0, 11 or so? Just want to show you different. I know some of us have gotten the answer right now. Oh, sorry. Some of us have gotten the answers already, but I want to show you different things so that in case you come across that in other questions, you are able to see. All right. 10,9. So, 10,9 volts. Remember now that RZ is not working, right? So, the 10,9 volts is actually here. And since these are connected in parallel, what does that tell us? That tells us that, thank you, Matlin. 10,9 volt tells us voltage is conserved in both of them. Okay. So the voltage here is 10,9 volts. We are already done, but like I said, different ways. So the voltage in Rx is 10,9. Why? It is connected in parallel. Do we know the value of R? We got 2,94. I think we can work out power. V squared over R. I need an answer quickly, and we're going to confirm with a different method. Our answers might be different because of decimals, but get me an answer and we're done there. Alan, 40 watts. Beautiful. 40 watts. Thank you. Let's try something else. I want to use ratios to do something for you. I want to use I squared R. But how do I get my ratio? Rx, this one for multiple choice, and Ry. This is 1:2. Remember, this is 2Rx. And I'm dividing 5, 5. Guys, this is what we do. We switch the numbers. How do I do ratios? Total ratio, 1 plus 2 is 3. But I know that the one with the smaller resistance should have more current. So it is 2 over 3 times. What's my voltage? No, my current rather, 5, 5. While this one is 1 over 3. So I just switch because they are inversely what? Proportional. Somebody wants to give me I. For X, since we are focusing on X, give me the current in X. Current of X must be higher than current of Y. It must be 2/3 of the total current. I need an answer. 2 over 3 times 5, 5. 3,67. Thank you. Thank you, girls. 3,67. All right. Now, can we use this formula? P therefore is what? And what is my R? 2,9 what? 7. Please give me an answer. We should have approximately 40 as well. I was just using that ratio to let us deal with multiple choice, that we switch the resistance if you are looking for current. Please get me answers. Or give us 40 watts as well. All right, guys, are we okay with the two calculations I did? Yes, it's 2 million.
Evening, sir.
Hi, to me.
Or afternoon, good.
Yeah, whichever one.
Sir, I wanted to ask, you were talking, or they were giving you the answer of 40 watts, right? So
Yes.
how did they get it from the 3.67?
It's written up there, 3,67 squared times 2 on top there.
Oh, we sent it back into the equation, okay, sir.
Because I have P equals to I squared R. All right.
Okay, sir.
Everybody good? Awesome. Especially on that ratio part. Don't forget, the one with the higher resistance gets the lower current. Okay, that is done. What do we have next? When both switches are open, the ammeter reading is 1,3. All right. When both switches are open, let's see what's going on. When both switches are open, what's happening? If we open both switches, which resistors are now in operation? Let's answer that first. If we open both switches, which resistors are in operation? If we don't get that right, we cannot get the questions right. Which resistors are in operation? Both switches are now open. All right, thank you. Rx is no longer in operation. We only have Ry and Rz. Good. Now we can work. Interpretation is very important. So we have Ry, R what? Z. We are told the ammeter reading is 1,3 amps. Calculate the reading on the voltmeter. Now, when they say the voltmeter, look at the voltmeter there, V. Calculate the reading on the voltmeter. We want this. What are we going to do? By the way, once we have the value of Ry, it's not going to change. What's our Ry? What was Ry again? 5,85. Beautiful. Don't forget, EMF is what? 12 volts. And R is? Because these things are connected in series. What do we know? Series are potential what? Dividers. Current is constant. Oh, that's so easy now. The current here will be 1,3A. Current here will also be 1,3A. So we are done. V equals to IR. That's number 4. The voltage in Ry. What's the current? 1,3. So that acronym is very important. You're done. We are done there. 4 marks or 3 marks? Quickly get me answers. Share your answer with me. Two 7.61 volts. Thank you very much. Now, switch S1 remains open while S2 is closed. Calculate the reading on the ammeter. Okay, let's see. Which one is S1 again? S1 remains open. S2, okay. All the resistors are now in operation. All resistors are in operation. Let's draw quickly. All the resistors are in operation. Okay. EMF is 12. R is 0.5. We have RY 5.85. We have 2.94. But we don't know Rx. Now, we are told that, so how do we calculate current? Bearing in mind that we do not know RZ. But I think we can get RZ though from the previous question. Because, okay, let's see if we don't have RZ. Let's see if we can work without, because that's been lazy now. Let's see if we can work. We don't know current, right? Bam, 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 bam. All right, we don't know current. I think we'll have to work out RZ from the previous question. So let's work out RZ. That's why it's 6 marks. Is R 0.2 or 0.2? Okay, thank God we haven't used it. But I want to see something. I want to see, can I do it? Can we work it out without getting RZ? Just want to see something quickly because everything has changed and RZ is unknown. We don't even know current. Okay, if I get my total voltage there, if we get our total voltage, our total resistance, we're going to have 2 unknowns. It's not worth the waste of time. Now, the resistors don't change values, remember, except we change the entire resistor or we use a rheostat. So, can we get RZ from the previous question? So we can bring that in. All right, you can bring that in. RZ, what do we know? Voltage, E. No, do we need that? Okay. I want to work it out without calculating that. But it's fine. From the previous question, what is my E? 12, 1.3, R plus 0.2, R total. Please get me R total, everybody. Do the maths. That R total will be Rx plus Ry. Get me a value. I don't want to do the calculations because I need you to be able to also put your input in it. Especially on calculations. 9,03. Now that's my total. But remember that our total is Rx plus Ry. No, Rz plus. Okay, so get me Rz. 9,03 minus 5,85. That's why it's 6 marks. Yes, 3,18. Thank you, people. Now, guys, haven't gotten 3,18. That comes here. May I ask you to please calculate I for me? We have everything we need. Use this formula. We have everything we need. Straightforward now. Please, I'll give you 4 minutes. Everything is needed. R there is our total. I'm just giving you 4 minutes in case you want to write. But please, that's not, I've done the hard work there. You have to calculate our total first because all the 3 resistors are now in operation. Quickly, please. 2,24. I have two answers. Can the rest please confirm? If your answer is different, then we can look at it. I have four answers now, 2,24. All right, to me, 1,48. Who else? 2,27. Answers are different now. If you know it's wrong, fix it, Nana. Fix it. Why is it wrong? Why should it be wrong? It shouldn't be wrong now because the harder work has been done. All right, so the first thing is I'm going to calculate my total resistance. I have a parallel connection, product over sum, and that is in series with RZ. I don't know if that makes sense. It's parallel plus series. That's my R total. Rx times Rz, no, Ry, over Rx plus Ry plus Rz. Okay, why is this board jumping? Product over sum plus R what? Z, because it's R1 plus R2. All right. And now, once I get that, I throw my answer straight in what? E equals to, okay, let's write the formula. Important. What's my EMF? 12. Now, whatever I get here, I add that to what? 0,2. Let's confirm quickly. It's my calculator. Product 2,94 times 5,85. Sum 2,94 plus 5,85 plus 3,18 because it's in series. That's my entire. Now plus 0,2, and then I'll say 12 divided by that. 2,248, which is 2,25. Did that make sense? Did that make sense? Awesome. So we're done there. Lovely question. I love the dynamics in the question, the changes here and there. Okay. Let's look at this one now, photoelectric effect. Two small spheres A and B of pure zinc are at rest, 0,1 meters apart on a wooden table. Sphere A is negatively charged. Let's put a note there. And it's free to move on the table, while B is uncharged and it's fixed. Okay, fixed, as shown in the diagram below. High intensity ultraviolet light of frequency that is now shown continuously on B. The work function of zinc is 6,63 times 10 to the power negative 19. Define the term work function. Everybody should be able to get those 2 marks for free. It is the minimum energy required to what? Eject an electron from the surface of a metal. Everybody okay there? Please, that definition is for you. Explain using a suitable calculation why ultraviolet shown on B will eject electrons. Guys, conditions for photoelectric effect. Photoelectric effect is basically one. E must be greater than work function. And I can transcribe this into F must be greater than F naught. Or that must be greater than the maximum. All of this will tell me that EK is greater than 0. That's the main thing. For photoelectric effect to occur, EK must be greater than 0. So, whenever EK is less than 0, we are simply saying no electrons ejected. That's the quickest or simplest thing to remember. If you don't know what to do, that's your safe haven. Calculate EK. Explain using a suitable calculation. Then don't write words, people. While the ultraviolet light shown. Okay, what do we know about the light? I think we can calculate E. What do we have? We have frequency, right? E equals to HF. What is E? H. 6,63, right? Times 10 to the power, negative 34. What's our frequency? 2,8 times 10 to the power, 16. You are using any of the conditions that I have written up there. If you are not sure, calculate kinetic energy. If it is negative, then there is no photoelectric effect. Somebody wants to help me with this answer? Let me just do it, because network is not unstable, so it might delay. But confirm with me. 6,63 times 10 to the power negative 34 times 2,8 times 10 to the power 16. All right. Is that what we have? Just give me a thumbs up. Thank you. Thank you, guys. 1,85. All right. 8564 times 10 to the power negative 17. That's what I have. Joules of energy. Let's compare that to 6,33. So, like I say, if you are not sure, look at what I'm going to do. E equals to work function plus kinetic energy. You are not sure of the values. Do this. EK therefore will be E minus work function. If you are not sure and the exponents are just playing games with you, use a calculator, don't stress. 1,8564 times 10 to the power negative 17 minus 6,63 times 10 to the power negative 19. All right, my answer is positive, which shows that electrons are ejected. I don't know if that concept resonates with you. Electrons are ejected because kinetic energy is positive. 1,79. Explain using. So now we've done a calculation. You can just say kinetic energy is greater than 0, which means that is E is greater than work function. If my kinetic energy is negative, then we say there is no photoelectric what? Effect. All right, I see that 10.3 was the issue in this question. But are we okay with 10.1.2? Let me know. We are okay. We almost get those marks. Oh, this is 2023 last year. Interesting. Okay, let's see. What is our new question saying? Sphere A carries a charge of negative 5,4 times 10 to the power negative 6 and carries and requires a minimum force of 0,027 newtons to move from rest. Let's understand. It needs that force. Calculate the minimum number of electrons or photons of ultraviolet light that must strike B, which will cause A to move. Interesting. Let's go back. We want A to move. So we are using, I see that we're dealing with charges, right? Good. So we have A And we are given the value of A as negative 5, comma what? 4 times 10 to the power negative 6. We have B. And B is throwing out electrons, which must collide with A. We want A to move. And we said the minimum force that this must have to move must be what? 0,027 newtons. What are we looking for? My dear learners, start from what you are looking for. Calculate the minimum number of photons. Interesting. Let's see. We're looking for number of photons of ultraviolet light that must strike B. Oh, check. Let's start like this. The number of photons usually would be equal to the number of electrons ejected. So basically, examiner is saying, calculate the number of electrons that will be ejected. We are looking at N. Interesting. How can we then relate? We are looking for number of photons, okay, of ultraviolet light that must strike. The number of photons can be worked out based on E. Okay? We can work it out based on E. Let's see something. Since we're talking about force, if we say F equals to K, Q1, Q2 over R squared, the force that must collide must be a minimum. Let's check something. 0 to 7. K is 9 times 10 to the power 9. Do we know QA? Yes. 5,4 times 10 to the power what? Negative 6. Do we know the charge on B? No. Charge of electrons. But what is the distance between them? 0,1 squared. May I ask everyone to please quickly get me Q2 as quickly as possible. All right. Nieni, please don't work in nano columns, okay? Always work with columns. Don't work with nano columns. Let's make it as simple as possible. Let's work with columns. All right, now, if we have that, 1 second, just need to quickly pick this. No. Now that we have our Q, what do we then do from there? Let me write your answer down. Okay. My Q is, okay, here we go. 5,56 times 10 to the power what? Negative 9. Now we are saying if Q can have a charge of 5,56 times 10 to the power negative 9, then we can produce a force of 0,027. But now, how many electrons will give us that value? That's what we need to check now. We know that N equals to what? Q over E. Remember they said it was neutral, right? 1,6. Let's get that number of electrons. Let's quickly calculate. Let's get that number of electrons. So we're saying if we can eject this number of electrons, we're going to have a force of that produced. What's your order you're getting? 3,48. Let's see, is that the answer we're getting? Network is a bit bad, so answers are a bit delayed. 3,48. Tumilengwa 47. I have 47. I'm seeing 48. Times 10 to the power what? 10 electrons. So if we can eject this number of electrons, it's going to create an electrostatic force. Oh, it's 47. 47. Alan says 47. There's no rounding off. All right. If we can produce 3,47 times 10 to the power 10 electrons, it will produce a force. And remember what I said. The number of photons must be equal to the number of what? Electrons. Oh, sweet. So the number of photons that we are looking for is actually 3,47. By the way, you must also know that the charge of a photon is the same as the charge on an electron in terms of magnitude. The charge of a photon is also 1,6 times 10 to the power negative 19. Only that it is what? Positive, while an electron is negative. Lovely question here, 6 marks. Did it make sense, guys? Make use of the information you are given. You are given force, you're given distance, so definitely examiner wants us to work with electrostatics. Very beautiful, I love it. Let's see, is there any question? Why aren't we rounding off? That's divine. I didn't calculate. What was the calculation looking like? What was the answer on the calculator? Yes, Amatle? Talk to me. Which step, Amatle?
The second step, the one is N equals to Q over E.
The question is, do you know when to use that formula?
When you want to calculate electrons.
When you want to calculate the number of electrons.
Yes, sir.
Good. So we have our Q. And our E is a constant, the charge on an electron. So we can simply calculate the number of electrons that will give us that magnitude of charge, 5,56.
Okay.
Are we okay there?
Yes, I understand what it says, sir.
All right, so we get the number of electrons, which is the same as the number of photons. Oh, I'm loving the arguments going on here.
Okay.
Okay. All right, guys, I'm sure you know. Alan, stop laughing. I'm just reading what's going on. All right, if you don't round off, okay, guys, we do not round off during the calculation, so you just keep using the answer button. I know we know that. We only round off at the end. But what we are looking at is the dynamics of the question and the understanding. I know calculations, you know what to do. We good? Awesome. So I don't know who gave me this one, but it doesn't matter. We are all just learning from. All right. I know the diagram here looks terrible, but it's quite straightforward. A demolition ball is used by a crane. Is it big enough? Let me see if I can make it bolder. I remember this question very well. It's Antile that sent me this one. She was all crying. Oh, sir, this question. And when I told her the last lesson that I won't be able to look at it, she was all sad. But we did look. Okay, let me. Remember, guys, it's not about a question, it's about the principle that we're applying to the questions. Hence, when I look at a question, I also mention things that are not in the question and just play around with them. Just want to make it bigger so I can annotate on this. All right, that's 5.2. And then from here, we look at the rest of the question, 5.3, with that information. Awesome. Quickly. Now, a demolition ball is used by a crane to break the wall of a building. The demolition ball of mass 1250 kg is lifted by the crane to a point R at the height of 5.8 meters above its lowest position. All right. In 60 seconds, define power, rate at which work is done. Everyone, 2 marks. Rate at which work is done. Calculate the average power dissipated by the crane in lifting the demolition ball to point R. First, I'll write what I know about the ball, and I'll write the formula for power. Number 1, I know the mass of the ball, 1250 kg. I know the time, 60 seconds. All right, I know the height, 5.8. I'm looking for power, work done divided by what? Time. Let's see. Interested. Work done. Now, it's work done by applied force. So we are looking for the work done by applied force. Can we, if we were to use this, work done by applied force over time, that would be force applied, delta y, cos theta. Please, guys, I know the examiner did not ask you for a free body. When you are doing question 2 and 5, draw. What do we have? We have the force of gravity, and we also have what? Applied force. Okay. Now, what do we know here? What can we deduce? What can we deduce? Now, they said the ball is lifted by the crane, all right, in 60 seconds. But what can we deduce about the force? This thing is actually not going to speed. It's going to move at a constant velocity. So we know that force applied is equal to force of gravity, and that would be mg. I hope that makes sense. So this is what? mg delta y cos theta over delta t. What is the mass? 1250. What is g? 9,8. What is delta y? Now, what is the angle? Please. This angle is 0. Why? Object is moving up, and the force that we are using is also moving up the same direction. Theta is 0. Here, theta will be what? 180. Take note of that. And time. What is our time? Time is what? 60 seconds. Please give me an answer here. Give me an answer. Somebody share an answer with me. (1184,17). 2 decimal places. Three marks in the bag. So it's important to be able to deduce that F, please. That's where the challenge is. Okay, we got. Next question says, the demolition ball is released from point R and strikes the wall at the lowest position. Please take note of that lowest. It basically means a height of 0. All right? The ball then moves 0.25 meters horizontally into the wall before coming to rest. Define the term conservative. Everyone should be able to do that, right? But don't forget, it is the work done. All right? Is what? Non-dependent, not dependent on path taken. So force whose work done is not dependent. And what's your example? E.g., gravity, electrostatics, electrostatic force. Those are not dependent. Is the force which the wall exerts on the ball a conservative or none? What would you say that? What would be your answer? Is the force which the ball exerts, no, is the force which the wall exerts on the ball a conservative or a non-conservative? Alan says none. Do we agree? Because the wall is actually applying, that's the language. Mieni. The wall is applying a force on the ball. The wall is applying. I am using the word applied, which means it is non non-conservative. It's an applied force. I don't know if it makes sense. The ball exerts a force on the wall. The wall also exerts a force. So it's an applied force, which makes it what? Non-conservative. I hope we remember our non-conservative force. Friction, applied, tension. 5.5. Are we okay there? Did it make sense? All right. State the energy conversion that takes place during the downward swing. This is grade 10. Let's quickly explain. We are saying EMEC is conserved because it's an isolated what? System. But at the top, kinetic energy is 0, potential energy is maximum. At the bottom, kinetic energy is maximum and potential energy is 0. Oh, what do you notice? In the middle, potential energy is converted to kinetic energy. That's what happens. So as potential energy decreases, kinetic energy increases. That's the conversion there. And we are done with that question. Potential energy is converted to kinetic energy. I hope we are good with that theory part. Now the last question. And I think this was where the question is. Using energy principles. Using energy principles. I like to always use one constant formula, which is work done by non-conservative. What would you do there? What would you do? All right, now let's look at what we have, my dear learners. Look, when the examiner says use energy principles, let's quickly break that down. These are the things that you should be thinking about. These are the things I should be thinking about. Work net equals to change in kinetic energy. Work done by non-conservative equals to change in kinetic. But this one, 5 star. This one is 5 star. Work change in kinetic energy. This one here, I need to put the star. Five-star formula. Sir, is EP and EK that? No, it's not. Good question. It is not. I'll tell you why it is not. Because in one formula we have a squared, and in the formula we don't have the squared. So they are not directly proportional. But what we know is that but let me see. Yeah, no, they shouldn't be. As EK increases, but don't use the word directly proportional. It's very tricky there because one's got a squared and anything that has a squared, we hardly go through that. Okay. But there's a graph. There's a graph for that. I'll try to draw the graph for you. Okay, guys, please look at my 5-star equation there. All right, Alan, if you can look for one for me, maybe not now, just so that in our next session I'll try to explain the graph, okay? I know what you're talking about. I know what you're talking about. I'll also search for one multiple choice that's got such graphs. But let's quickly run here. Now, using energy principles, calculate the magnitude. Guys, let's understand the question. The demolition ball is released from point R and strikes the wall at the lowest point of the swing. The ball then moves 0.25 meters horizontally into the wall before coming to rest. Let's try to create a little diagram for us to see what's going on and understand it. Okay, so it moves into the wall a distance of 0.25 before coming to rest. So we have, it strikes the wall, but do we know the velocity with which it strikes the wall? No. But we know that the velocity here is 0. It swings down. Okay. All right. Now, let's look at what we are calculating. The examiner, guys, always start from what you are calculating. Read the question well. Calculate the average force exerted on the wall. One thing I know about force is this. F net is equal to what? MA. Ooh la 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 la. I know M, but I don't know A. Okay. Oh, but the examiner is giving me a horizontal motion here. Okay. Which means I can get my acceleration if I use equations of motion. Because I know delta x. Okay, what's my equation? Vf squared equals to Vi. I'm cutting out time. But I have a problem. I have my final velocity, but I don't have initial velocity. That is where energy principles actually come in, guys. This part is where your energy principles come in. With energy principles, you know what I'll be able to do? I'll be able to get the velocity just before it hits the wall. All right, before it hits the wall. Once I get that, how are we done? So let's write that formula quickly. When I get that, check the process. I'll get VI. Once I get VI, I'll be able to get my A. Once I get A, I'll be able to get F net. This is the thing that comes to my head at the moment. Work done by non-conservative equals to change in kinetic plus change in what? But that point is isolated. So work done by non-conservative is 0. In an isolated system, the work done by non-conservative is 0. Okay, what is my formula here? Half m Vf squared minus Vi squared plus mg h final minus h initial. Oh, by the way, this height is 5, what? 8. Is it 5,8? 5,8 or 6,8? 5,8. Beautiful. So this height is 5. Oops, what's a guan? 5,8. All right, let's work. 0, half, 1250. What is my final velocity when it collides with the wall? I don't know. But initial velocity, guys, do you see where I wrote my work done by non-conservative? That's where I am right now. Not yet on the horizontal. What is the mass? 1250 again. What is G? Now, what is the final height? Final height is at the horizontal position where it hits the wall. Final height is 0. Initial height is 5,8. Please do maths for me and get me VF. Do the maths quickly. Get me VF. Do the maths, get me VF. Okay, 10,66, that's what you guys are giving me. I hope everybody knows how to get that value. But let me confirm. I've got trust issues, you know me. Okay, so what I'll do is I'll say 1250 multiplied by 9,8 multiplied by, I'm just going to say 5,8 because I'm moving it over. It's going to be a negative there. I move it over there. All right. And then I'll multiply by 2 and then divide by 1250 and then look for the square root of that answer. 10,66. Beautiful. 10,66. Now, this final velocity becomes my initial velocity when it comes to equations of motion. Vf squared. Now we are on the horizontal part. Please don't get confused. We are on the horizontal part where the final velocity, this is velocity, velocity with which it hits the wall. Okay, what's my initial velocity now? My initial velocity now is 10, what? 66 squared. I do not know A, but I know my displacement as 0,25. Guys, let's find A. A must be a negative answer. Why? The object is slowing down. Let's try it. Please find A for me. Have expectations as well. It's important. Anybody done? Beautiful. You see, we're getting the negative answer, right? I hope you understand why it is negative. Negative 227,27. Now, F-net. Because for the object to stop, please understand, for the object to have stopped, the force must be in that direction. Force that stops the object. So it must be a negative force. That's why we're going to get a negative answer. What is the mass? 1250. Let's calculate. That's the answer multiplied by 1250. Let's see what we're going to get. There are so many ways of getting this particular question. So many ways. But what is your answer? Try to use the answer button and just continue so we don't round off. $284,087,5. Confirmed? Yes, Sbu?
So when we are rounding off, do we just, let's say we complete a sum, do we just write through, keep on the answer, and then round off at the end?
Yes.
And then when rounding off, for what decimal place is it, 2 or 3?
2 decimal places.
Okay.
2 always. Alan, sir, in some memos of this question, they say use energy principles only. I see that they said if equations of motion is used, give 0. How will you know? No, but we did use energy principles, you see, because we used energy principles, you are allowed to then use equations of motion. I don't think in this memo they cannot penalize you on that, because you did use equations of motion first. I don't know if what I'm saying makes sense. We did use equations of we did use energy principles. There we used equations of motion. So here you will not be penalized. If I didn't use energy principles at all and I just use equations of, because I can do this with equations of motion. Like, let me tell you which one will be wrong. Look at this. Look at this. This one now will be marked wrong. The first part. VF squared equals to VI squared plus 2A delta Y. Object starts from that. It's a free fall. And that is 5,8. Please get me an answer here for VF. Get me an answer there for VF. I hope, guys, this 10,66. Make sure you use the answer button, please. Don't round off. Use the answer button and continue with the answers like that. Do you see, Alan? It gives me 10,66, right? But here now, this part is the same as this part. Where is it? There. But if I use this option and continue with this option, I'll be marked wrong. Why? I haven't used energy what? Principles. Does that make sense? Angela, square root. Did you find the square root? Alan, are you okay? Yeah. So it's still correct, but I'm restricted to energy what? Principles. So this one now will be marked wrong. But if I start with energy principles and complete it with equations of motion, then I'm good. Okay. All right. What did you say this answer is again? Didn't write it down. 2 something. 284 blah blah blah. Can you retype that for me? Okay, let me just scroll up. All right. 284087,5. Beautiful. But remember, I have to get rid of that negative, because the negative only tells me the direction of the force. All right, caution, please don't round off during the calculation at any point. Keep using the answer button, all right? Or rather, if you can get a fraction, use a fraction. But keep using the answer button until the last answer, and you round off to 2 decimal places. I hope everybody's good. Question done. All right, the same question here from the same paper. Here, I think examiner is trying to see if you know equations of motion. How to deal with vertical projectile motion without using equations of motion, especially when it comes to the graph. Whenever you see a graph like that, I'm going to take some time. Can I have this as my last question for this particular session? Let me see. In case, I know there are still a lot of questions. I got more today. Ooh, there we go. Not a lot. Okay. But let's do this as the last one. I promise you all of this we would get through. Don't worry. A ball of mass 0, because this may take me time, I want to explain a few things. And if I see I can still answer one more, I will do it. A ball of mass 0,06 kilogram is thrown vertically upwards from the balcony of a building 3 meters above the ground. The ball reaches a maximum height. Guys, let us start by doing something. Let us sketch. The ball was thrown up and it comes down. And we were given the height from which it was thrown from. 3 meters. Let's call this A, B, C, and D. I like to label. All right. Ignore the da. Name the force acting on the ball while it's in the air. Please don't write gravity. You say the force of gravity. Just write gravity. The velocity time graph below represents the motion of the ball from the instant it is thrown up until it hits the ground. Beautiful. I love this. Write down the acceleration of the ball. Now, acceleration. Guys, let's quickly look at something before we even answer this question. Let's connect the graph and the sketch. Let's connect the graph and the sketch. If I were to draw a graph of velocity time graph, let's take upward as positive. So that will be positive. That will be 0, negative, and negative. Check here. If we can do this, if you can understand this, graphs becomes very easy for you to do. All right, A is positive. Beautiful. B is at 0. And then C increases. Or C is at the same level as A. And then we have D further down. So that if I take my ruler and draw, I have that. Let's label together. If you can do this, we're good. That is A, the beginning. That is B. That is C, the same height as A. And that is D. I have transcribed my position into velocity time graph. Now, what do we know? It's a free fall, guys. Acceleration is what? 9,8 meters per second squared. Where? Downwards. Write down the acceleration. We are done there. Yes.
So if it was not free fall, then we would now need to calculate the acceleration.
Yes.
If it was not free fall.
Yes. If it's not a free fall, then we would need to calculate acceleration. And you can actually see that this is a negative gradient. I don't know if you see that, right? Negative 9,8. and G is always acting down. Oh, so the examiner has taken down as negative, up as, we're done. So if you check AB, do you notice AB on the red graph? What's happening? Up. But B to D, what's happening? Down. Negative there. Okay, guys, consider the areas A1. Please take note. This is the very important point. Area of a velocity time graph is equal to displacement. And the gradient of a velocity time graph is acceleration. Two important points there. Whenever I see a graph, that must come into play. The area is displacement, and the gradient is acceleration due to gravity. And we can prove all of this with a calculation. But let's just accept that for now and move on together. All right. Consider areas A1 and A2. So those are two areas. Write down the numerical value represented by the difference. Let's see what the difference would be. Where is A1? This is actually A1. A1. And what? This is my A2. Oh, where's A2? A2 is that. Okay, my beautiful learners, let's check. It makes sense. A1 is between A and B. A2 is between B and D. What's the difference between the two of them? Do you notice the difference is AD? And they said, write down the numerical value. My answer is 3 meters. Let me know if that makes sense. By using the graph. Let me explain again quickly. They said between A1 and A2. Where is A1? A1 is BD, AB. There we go. Height, maximum height. What about A2? A2 is BD. Can you see that whole area? Oh. What is the difference? The difference is what? AD, which is 3 meters. Let me know if that makes sense to you. Let me know if that interpretation makes sense to you. If the 3 meters resonates with you. That would have been very difficult if we don't understand the story and the theory of graphs. All right, 3 meters. Next question. Calculate the speed at which the ball is thrown upwards. What do you know? We can do this in two ways. We can do this in two ways. We are looking for the initial what? Velocity. Remember, we have chosen upward as positive. Let's see. 3.4.1. Let's write what we know first before we choose a formula. Vf equals to 0. Vi is unknown. Blah, 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 blah. What do we know? G, we chose upward as positive, downward is negative. Okay, is there something I'm missing? I see there's a missing variable. All right. Oh, we have time. Yes, I was just noticing that there's something missing. 1,02. Time to reach the maximum height. Good. You see why I do my stock taking? To see what is missing. So what do we have? Vf equals to what? Vi plus A delta T. Vf. Can you guys calculate Vi for me quickly? 1 second. I need you to do, where's height? I want to see the height, h. All right. Maximum height above the ground. I want you to do both for me quickly. Let's get those 4 marks quickly. I think in 4 minutes we should be able to do that, or 3. But let's make it 4 for everyone. We should be done, guys. These questions don't take that long. All right. I see you guys are giving me answers 10. Beautiful. So we're saying 0 equals to, I read. Let's cut that time. Do we know VI? No. Plus what? Negative 9,8. So you're getting VI as positive 10, right? But look at what I could have done, guys. I want to show you something. If the examiner says you don't use equations of motion, look at this. I want to show you what we could have done without equations of motion. They gave us a graph. This is 0. We don't know this. We know this as 1,2, 1,02. But here's the trick. What is the gradient? It's a negative gradient. Let's calculate gradient. What's the gradient formula? Change in y, which is change in v, over change in t. Negative 9,8 v2 minus v1 over, all right, if I call this my second point and call this my first point. So v2 minus v1 over t2, 0 minus 1,02. What is v minus that? That is v. Please cross multiply for me. You are going to get 9,8 times. I don't know if you see that we've come back to the equation that we had. 10 meters per second. So if an examiner says do not use equations of motion, that's what I'm going to do. I'm going to work with my graph. Does that make sense, everybody? Without equations of motion. Can you see? I'm getting the same answer. 3.4.2. I'm going to work out both ways again. All right? So we must know how to work without equations of motion. What are we looking for? The height. Please make sure you check the question well and see where the height is. It's from the ground. So we can calculate the maximum height reached. All right? We can calculate the maximum height reached. Delta y, no, let's use which one? We have time. Great. Equals to VI. Anyone would work. Time is 1,02 plus half negative 9,8 and 1. Please give me an answer to this. Give me an answer to that. Oh, Alan, 8,01. Is that what you're giving me? Confirmed, everybody? Wait, which height is this? Is this for this calculation that you're giving me? I'm looking for the maximum height from the point of release. Oh, you already added the 3. Just wait before you add the 3. Before you add the 3, 5,1. Before we add the 3. Check this. Before you add the 3. Can I do this without equations of motion? Again. 1,02, 0, and 10. Let's look for the area. That's a triangle. Always use the x-axis as your base. Half 1,02, and what's the height? 10. Give me your answer here. This will give you exactly 5,1. It will give you exactly 5,1. Can you see I have the same answer? Equations of motion and the graph. But then I know my h, therefore, will be 5,1 plus what? 3. Are we okay? I could even use energy principles to get this. I'm not restricted here. Someone said energy principles. Yes, you can use work done by non-conservative. You'll get the same answer. All right, please take note when you are using equations of motion, x-axis must be the base. And also use the negative if below the x-axis. Use the negative. For example, your h at the bottom will be negative. Please use the negative as part of the work. I'll see if we can quickly show you that. All right. I hope everybody is good. What is the next question? After hitting the ground, the ball bounces vertically upwards and reaches a new maximum height of 1,1. Let's try to draw this quickly. I like to always create an image. That's what I have. 3. 1,1. All right, diagram not drawn to scale. It reaches that maximum height. Let's see. Calculate the work done by the ground. Okay, while the ball is in contact with the ground. Thank you, sir. Calculate the work done. All right, let's see. Calculate the work done. Now, by the ground. How are we going to get that? First is to think of the formula. The work done formula. What would that be? The work done formula. Let's think of that. Now, the ground, this is what I will do. The ground is actually applying a force, right? Which means it's a non-conservative force because it's force applied. Okay, let's write that down formula and try to create what we are looking for. Work done by what? Non-conservative equals to change in kinetic plus what? Change in potential. Great. The work done by non-conservative. Now, but here is the thing. The question says, while the ball is in contact with the ground. Contact with the ground. What does that tell me? H equals to 0. Does that make sense? The ball is in contact with the ground. H equals to 0. Therefore, work done by non-conservative, or let's interpret, work done by the ground, since it's applied, will therefore be equal to change in kinetic energy plus 0. I hope that makes sense. I hope that makes sense. Okay, let's break this down. What is this? Half m Vf squared. All right. Where is my Vf? We are focusing on this point. So it hits the ball, Vi, and it bounces back off, Vf. Please, per point, always understand your Vf and your Vi. My dear learners, can you get the velocity with which it hits the ground? Velocity with which the ball hits the ground. Let's find that first. What do we know, my beautiful learners? Please, this is very important. Can I go to a new page? Because I want to do something here. Now, there's something that usually confuses learners, and I want us to get rid of that. Let's find the final velocity here. We know the initial velocity. What did we choose? Upward as positive. Now, what do we know? 3 meters. Vi is 10. We are looking for Vf. Upward as positive, G is negative 9,8. This is where the confusion is. What is delta Y? Now, displacement is the shortest distance from the starting point. I'll repeat. Displacement is the shortest distance from the starting point. We are starting, or did we label this? We did. A, B. The confusion is here, delta Y. What is my delta Y? What is the shortest distance from where we started to the ground? Do you need to go up? No. You just go down. Because this is the start and this is the finish. The shortest distance. You don't have to climb up and down. Just go down straight. And down is negative. That gives me negative 3. That's where learners miss it. Learners gladly miss that negative very, very well. Let me know if it makes sense, please. Learners throw that negative away with all delight. The shortest distance, you are starting from A going to D. You don't go up, you just go down. And down is negative. Sweet. So, can I then calculate my final velocity? Vf squared, Vi squared, 2a delta y. 10 squared plus 2, negative 9,8, and negative what? Once you see that you have to calculate the square root of a negative number, know that you are wrong. You see, if I did not do that, I would be getting a negative value. So what do I have? Square root of 10 squared plus 2 multiplied by negative 9,8 multiplied by negative 3. All right, it's 9,8. If you don't do that negative, you are going to get an error. Let me try. Let's see. I want you to see something. If I don't put a negative, oh, this answer is wrong though. But sometimes you get a negative, you get an error. All right, this is the correct answer, 12,60. I hope that makes sense. 12,6. Oh, but I didn't want to round up. Okay, guys, we would use the answer button, right? We would use the answer button. All right, on your calculator. Now I know the velocity here, but it has to be negative. We'll deal with that. What about the velocity with which it bounces up? Let's draw again. The object bounces up and reaches a height of 1,1. Let's see. Final velocity is 0. I do not know my initial velocity. My g is still negative. Don't change it, please. Don't say, oh, now object is going up. You don't change that. Nay in Afrikaans. Okay. Please, we don't change. Don't say, okay, it's now going up. Maintain what you have chosen. All right. Question is, what do I have? I have V. See, it's kind of easy for me when I make. Some of you are very lazy to do this, and that's why we struggle. What is my delta Y? How are we going? We're going up this time around, right? And up is positive, so delta Y is 1, 1. Can we use the same formula? Let's use the same formula. Vf squared equals to Vi squared plus 2a. What's my Vf? 0 squared. What's my Vi? Unknown. 2. What is my A? Negative 9,8. And what is delta Y? 1, 1. All right. What is my Vi squared? Or Vi? What is my Vi? I'll say, when I move it over, it becomes positive, right? So 9,8 times 2 times 1, 1. I hope my sign makes sense. Move the negative over, it becomes positive. Now square root of my answer, and I have 4,63. Let's use 4 decimal places because I don't want to round off. 6433. All right, 6433. That would help. Give us more perfect answer. Can I quickly redo this one? Square root of 100 plus 2 times 9,8 times 3. All right, 6016, 6016. Now, if we go back to where we started from, where did we start from? The work done by the ground, which is applied, is change in kinetic what? Energy plus 0. There's no height increase. 1 over 2 m Vf squared minus, sweet maths. We were given the maths, right? This is why they gave us the maths. They had this question. Waiting for us. What is the maths again? 0,06. I don't know if you see that we are done with the whole question just like that. 0,06. Final. Now, my dear learners, good. Which one is the final? Which one is the initial? You've got to be careful. Remember, this object hits the ground and bounces back up. Hits the ground with what? Negative 12,6016 and bounces back up with positive 4,64 based on the direction we chose. Up as positive. This now becomes my initial and that becomes my final. 4,6433 squared minus negative 12,6016 squared. Please give me a final answer for the day. Those of you that I didn't get your question, please relax. We will get there. Time is just up for now. Please give me an answer. And our answer should be negative though. Yes, our answer. We chose up as positive and down as, what did we choose? We chose down as negative, up as positive. Okay. What's our answer? Negative 4,12. All right. 1 second. I want to just check something quickly. Guys, look at the mess. Look at the mess up. Look at the mess up. We all messed up. Did you see that? Okay, it's my bad, but no one corrected me. Reaches a new maximum height. I just read that as, now, some of us do this in the exam. We do this in the exam. We assume that we know what the examiner is saying. So you please learn from my mistakes. If you make the same mistake I made right now, then I'm better than you. Okay. It was in 1.1 second. Okay, it's not going to be a lot of correction. It was in 1.1 second. Let me clean this. All right, we know the time, so our formula is wrong. Oh, let's fix it quickly. It won't take time. Yeah, that is not the 1.1. In 1.1 seconds should be here. So we do not have delta y. We do not have delta y. What we have is delta t. Let's fix it quickly. It's not going to take time. So our formula is wrong, right? That's the thing. Oh yeah, we can just use that simple formula. Sorry about that. I'm hungry, I guess. 0 equals to VI plus, what's our G? Negative 9,8. 1,1. Okay, please give me initial velocity. So it's not this 4. It's not 4. And that's the only correction we're making. What is VI? Share that answer with me. What is VI? Angeli, 10,78. Is it confirmed? Confirmed? All right, give me the final answer now. Just put that 10,78 there. Final answer, I'm waiting. Negative 1,28 says a Martley, Chumeleng, negative 1,28. Please don't leave your answer, just come back here and put the answer as positive. All right, negative gives you the direction. Are we okay? And you learned some new things about graphs and all of that. Everybody okay? And my error, you also learned from my mistake. Okay guys, the rest of the questions we will answer in our next session, but please let the questions keep coming in as I put them together. Every question will be attended to because it gives me a sense that you are studying and you're getting stuck, and that's where you're getting stuck. Once we get to your question, you are excited, and that's done. All right, guys, have a beautiful, beautiful evening. The lesson will be available almost immediately, added to the playlist. All right, I'm going to try to just upload immediately. So in the next 15-20 minutes, it should be available for a rewatch. Have a lovely evening. Thank you, and thank you. Yes, Arifa. Yes, I'm with you, Arifa. Oh, you were giving me a clap. Not clap, but hands together. Yeah, don't clap like that. All right. Okay, guys, every other question will be dealt with in our next session. I'll see you shortly. Goodbye.